again guys, please concentrate. Hadoop has given up a solution, bringing up in such a way that the optimization procedures or the search criteria done on this kind of huge amount of data is very, very minimized. The more the data is, the more the fast and the search capabilities are. That's how Hadoop is designed. You go on increase the data, let the data go on increase. I'm least bothered about it. Hadoop says, I'm okay. I know how to handle the data. I know how to cluster the data. I know how to optimize it, start analyzing it, and then determine the value. Okay? Are you all getting what I'm saying, everybody? So to start working with the challenges that always comes across in a real-time scenario is, how do I transfer my current database management system into Hadoop file system? How do I visualize one location to another location? Okay.
Yes.
So the migration is the biggest hassle, guys. Biggest hassle. Trust me, it's not that easy. Word migration is like the biggest hassle. Transferring and analyzing and visualizing the statistics in a complete local storage information, or maybe in a data center, or maybe in a cloud interface, is like a biggest hassle. And trust me, Hadoop file system is a beautiful solution and the best answer to look after that. And one of the best examples here is my stock markets, NYSE, New York Stock Exchange or something. Any stock exchange which looks after everyday routine, they will have 1 terabyte of data, traded or non-traded, in terms of performing a stock or maybe non-performing stocks. And every stock performance independent person has to analyze and determine the optimal trade procedures. And for your information, there are almost like, if you see the slide, the last point saying 294 billion emails were sent every day to analyze the data and find the spams. Trust me, billion emails is not that easy to be handled. So the best solution for looking after this is, let me go to the next slide. This is what big data does for you. At the end of this module, you will be able to understand what and how big data are the solutions, analyze the limitations which exist the data analytics architecture, understand what Hadoop is, Hadoop's ecosystem, core components, how do you perform read and write in Hadoop, understand the RAC awareness concept. Now, what is a RAC? Guys, big data uses something called as a layered architectural procedure, which is called as HDFS. HDFS stands for Hadoop file system, wherein you will have independent nodes. Guys, nodes are something like independent servers on a specific location, and each node will be concentrated with or named after something called as a name node, NAME, name node. I'll show you the architectural design and layer, don't worry. Just be with me in understanding the theoretical part, okay? If you don't understand, please stop me, guys. I'll repeat it again, everybody. Now, talking about the features in additional, Hadoop file system has a noding concept which will have a cluster or a rack. Now, I have like 5 different data centers. In each and every data center, I have like 5 different racks independently. That means 5 into 5, 25 different racks all over in 5 different data centers. Maybe data centers are located in various locations. All the requests that are coming up from one data center to other data center are completely optimized through Hadoop file system, basing upon the request and the response process. Means we are like how many people? We are like 10 people in this bridge right now. Each 2 people is assigned to one data center, for example. Each person, 2 people are assigned to a data center. If a request is coming from an additional person who has joined into the bridge currently, where should his request go? To which data center his request has to be redirected? Do I have to direct him to the first one, second one, or third one, or fourth one, or fifth one? This is what is racks are. Racks decide, or the Hadoop file system decides, how should you design your ecosystem? How should you redirect the requests coming up from one person to another person? Send it across to various people so that they can access the data and they can start propagating their data in a perfect manner. That's what the beauty of Hadoop is, guys. The next slide is talking about. I just gave you a small unstructured data format. Guys, unstructured data is something like We don't know who the customers are in the business. Something like, in our non-technical terms, you can call it as window shopping, guys. Normally we do that at a lot, right? We do window shopping, and and we go to various malls and then we don't even purchase. But the business person will look after such kind of customers, and they analyze what they are interested in, and they need to store this entire information at some place. Trust me, this is called as unstructured data format, which is not ready or which is not useful for the business, but still I have to store it. Where should I keep such kind of unstructured data? And valued business process, like a person who does actual purchasing, is considered as a structured data. So there are like unstructured and structured data formats which we have to store at a location. For example, if you see on the slide, it's expected like by 2020, the International Data Corporation is predicted that it has reached 40,000 EP or 40,000 zettabytes of data by 2020. And imagine on a daily routine how much data is being included into the clustering process. And also it's also said that the world's information is doubling every 2 years. By 2020, there will be like 5,200 GB of data for every person on earth. That's what they are looking after. Now, where is this data coming from? Where should I store this data from? Where should I structure it? How do I look after? And first answer that comes always is HDFS. As I said, you will always be able to handle and optimize the HDFS process and run them as a cluster. Now, talking about definitions about big data, these are the main important points, guys. IBM has given up a specific definition talking about volume, velocity, how much of volume of data is coming in today, how much of volume of data did I receive yesterday, how much of volume of data I'm going to receive on tomorrow, a prediction. Based when you decide upon the volume, you will decide upon velocity. Velocity means the responsive time. How much time do I need for attaining certain volume of data? How much time I need, or how much scope I need to store the volume of data which I'm getting on a daily routine or hourly basis. Once I have the velocity, I need to segregate them into variety. What sort of data has been taken into consideration? Which variety or is it falling under? Which domain is it falling under? Is it related to healthcare? Is it related to insurance? Is it related to banking, telecom, retailing, whatnot, guys? Every domain related. That is called as, differentiating a conceptual process of a data is called variety. So we are done with volume, we are done with velocity, we are done with variety. Then comes veracity. Veracity is something which